Hi, this is Phil, and this project is my most ambitious weather station. It includes 4 microbits and 2 Sparkfun weather kits. So let's have a look at it. It's meant for both indoor and outdoor, and the outdoor arrangement looks like this. All of the electronics is housed in a Stevenson's weather box, and it gives protection against hot weather and also the rain. So here in this outdoor arrangement, I'm measuring with one Sparkfun weather kit the wind speed, direction, and also the rain. The other one measures soil temperature and soil moisture. And both Sparkfun boards measure the temperature, pressure, and humidity. And all of this is compared against a Netatmo weather station. So this is what it looks like inside the Stevenson weather box. And on the left, there's the weather bit from Sparkfun with the connections to soil, connections to the wind speed and direction, and also the rain gauge. And on the right, we have another Sparkfun weather bit, and it's connected to the soil temperature and soil moisture. And in the middle, we've got a Netatmo weather module. So we're on the soil measurement device. We're logging all the results onto a micro SD card. But on both of them, we're also transmitting all the weather parameters on the Microbit radio. And because we had some radio problems, we've added a Microbit repeater. And this is what it looks like. The Microbit repeater is housed inside, and the Microbit sits on top of a bit maker, and it's connected to the I2C port to a BME 280 for inside weather measurements. At this stage, these weather measurements are not transmitted. So to have a look at all of this, I've got a mind map, and I've been doing the original project about 4 years ago. So this is really an update. The timing was that back in 2017, I received the 2 weather kits from Sparkfun, and I demonstrated those at Osbury in November 2017. So I've updated all this, and the updates are mainly looking at improved radio transmission, monitoring outside in a proper weather enclosure, and having simultaneous and multiple weather bits and weather stations. So just a quick revision of the weather bit, and you can see how the ports, how the pins are allocated to Microbit using the weather bit. And the nice thing about the Sparkfun weather bit is that everything's open source, and that's unlike the DF robot weather station, where there's very little additional information on the technical side given to you. So here are the projects that I've done this year, and I'm doing these incrementally, looking at unit testing of wind, rain, then gradually building up to the final project. So I won't describe all of these here, but I will give you the results. So starting off with the wind, each of these are separate projects, and they contain the objective of the project, the hardware involved, the software, the results. And just looking at the wind measurements, everything's based on the microbit. And for the wind measurements, we're measuring wind speed and wind direction. And of course, all of this has to be mounted outdoors and has to be robust against the wet weather. Here are the connections for the wind. And since we're dealing with Sparkfun, we're using USA measurements, and we have to add the additional conversion to metric units. And this is what the very simple software code looks like. Here, just for the wind speed, and wind direction, I'm logging everything onto a serial port. And if I do the same with the wind speed, here's my arrangement outside. And you'll notice while I'm setting this up, I haven't got an ideal arrangement. The wind speed and direction is far too close to the house, and it should be put quite some distance, at least about 10 meters away from the wall of the house. So the objective here is to measure remotely wind speed and direction, the rain, and also to measure the temperature, humidity, and pressure remotely. Locally, I have a gateway computer that can also measure the temperature, humidity, and pressure. And I want to compare all this with Netatmo, which is my commercial weather station. So I'm going to provide on each of the measurements a timestamp, and that will be provided at the gateway. And I'll be using a software real-time clock to do that. And each radio packet will be identified with the station number and a log number. And this will be transmitted every minute. So part of the project is to make sure I've got the correct units, and I'll be able to make comparisons with the Netatmo gateway. Also important to have all the results, all the measurements in Microsoft Excel format for any further analysis. So this is the hardware that I'm using, and it's all assembled. And for the radio repeater, I'm going to use the bit maker together with the Grove BME 280 weather sensor. And this is what it looks like for rain and wind. You can see that the connection between the outdoor unit, which is on Microbit 1, is connected via Microbit radio to Microbit 2, which is indoors. And the connection for the Grove BME 280 is on a I2C connection on the gateway Microbit. It's also interesting to see that the BME 280 is also embedded on the Sparkfun weatherbit. And for a second weatherbit. I've got the soil moisture sensor and the soil temperature sensor connected. And it's also connected to the same gateway microbit indoors. So for the software, for the weather, for the Sparkfun weather and radio transmitter, this is what the blocks look like on Microsoft Make Code. And everything's in a modular arrangement, starting on the left with initializing parameters and setting up the functions on startup. The forever is simply a polling routine that waits 1 minute sample time before it goes and gets on the next column, which is a function for the get environment parameters. To help with the debugging, the next 2 columns relate to what happens when you press button A on Microbit. So you can see the local parameters on the Microbit LED array. Or alternatively, you can see those results on a USB connection to a notebook computer. But the column on the far right is the one which is used to log all the weather parameters via Microbit radio. So here we are on startup. Here's the routine to connect to the radio group 1 on Microbit radio. The weather, wind, rain modules on Sparkfun, all of those are started up, and the various parameters for conversion are then sent. Right at the near the end of the startup, I'm also sending a header for all the parameters that I'll send via radio. And the get environment routines are then shown. We log, the log number is incremented each time we go through this, and we're collecting the wind speed, making adjustments for that, wind direction, and only locally wind direction is shown as a upper numeric, either N for north, northeast. But when we transmit via Microbit radio, everything's been transmitted via a number. So north is converted to 1, northeast to 2. And that just helps with the management of the packets, the radio packets on Microbit radio. So if we press button A, we can view those parameters on the local Microbit LED array. And to log the results, we just simply put everything in a Microsoft Excel format, which has commas separating each of the parameters. And we do something similar with the radio. This has been modified since to add the commas and the station number. And this is what the results look like. We get everything transmitted and captured by the gateway every minute. And we've satisfied all the objectives of this project. In this initial project, I didn't identify the station number at each of the remote sites. So some of the issues that I came across, that I couldn't use time stamping using the software real-time clock, just wasn't compatible with the Sparkfun weather module software. Also, I had trouble with the conversions on Sparkfun, particularly with the pressure measurements. So some of the other issues that relate to that, I had to change the Sparkfun pressure units, and also the proximity to the buildings was too close. So I've now scaled this up now so that everything is working together. That is, there's 4 stations now involved. There's a gateway that connects to the PC. There's a radio repeater that sends on the radio messages or packets from the other 2 stations, Station 2, which is the rain and wind, and Station 3, which is capturing the soil measurements. Each of the indoor stations, Station 1 and 2, have Grove BME 280 weather sensors. And here are the results of all that. Everything is working. That is, I'm using timestamps. I'm monitoring both locally and remotely. I'm logging the soil results at temperature, the local temperature in the Stevenson box for temperature, pressure, and humidity onto an SD card. And I'm also identifying and transmitting the station number for each packet. I've corrected for time measurements, and I've now got the correct units. So all of this is compatible with Microsoft Excel, and I've also compared the results with Netatmo. So here is the results on Netatmo. The top is for temperature, and the reading on Netatmo is 13.5, which compares favorably with all 3 temperature measurements in the Stevenson box, 13.9, 13.7, and 13.8. Similarly, with the humidity, the Netatmo is 80, and I'm getting 74 and 76. The pressure measurement is a little bit out, and here I'm getting 1030 millibars compared to 1007 and 1010. And for future, the Netatmo is measuring carbon dioxide levels. And in the future, I want to be able to take my own carbon dioxide measurements. Okay, so this is what I'd like to do in the future, is to add the BME measurements to both the repeater and the gateway, and to add new measurements for the outdoor sensors or the outdoor stations for ultraviolet radiation, sunlight, carbon dioxide, and particulate matter 2.5 microns particles. So it was an interesting project, and while it took about 4 days, I was quite happy with the results. So here are my references, and I lean heavily on the Sparkfun website, which gives excellent help regarding the unit testing for all of the modules, all of the sensors. And one of my final goals is to connect to Weather Underground so that I can be a weather station on this global network. So thank you for listening.